Now, the next topic is orthogonal trajectories in polar coordinates. Orthogonal trajectories in polar coordinates. Orthogonal trajectories in polar coordinates. Now, what is the polar curve general representation? Let the equation of the polar curve is equation of the polar curve be f of r. Polar coordinates are what? R comma theta comma, and there is one arbitrary constant, that is c. Take this as equation 1. Okay, let the equation of the polar curve be f of r comma theta comma c. Okay, then what is it? This is step 1. Step 2, to eliminate the parameter c, by differentiating equation 1 with respect to theta, then we get the differential equation. Of the form. What is the differential? I am taking capital F. R will be there, theta will be there, and in place of that is c is eliminated. Dr by d theta equal to 0. Okay. Then third step, to find orthogonal trajectories. OT stands for orthogonal trajectories. To find orthogonal trajectory of equation 1, replace dr by d theta by minus r square into d theta by dr. Minus r square into, what is this? Remember this. Minus dr by d theta is replaced by what? Minus r square d theta by dr in equation 1. Then in equation 2. Then what about 2 implies? Then it becomes capital F of r comma theta comma minus r square d theta by dr equal to 0. Equation 3 is the differential equation. Is the differential equation of the orthogonal trajectory family. Okay, differential equation of orthogonal trajectory family. Next, step 4 is solve equation 3 to get the equation of family of orthogonal trajectories. This is the procedure. Once again, what is this? First, let the polar curve be f of r comma theta comma c equal to 0. C is the parameter, one parameter family of curves, and to eliminate constant c, differentiate the curve with respect to theta. Okay, then I get the differential equation for the curve 1, that is capital F of r theta dr by d theta equal to 0. Then to get the orthogonal trajectories, replace this dr by d theta by minus r square d theta by dr in this differential equation. Then after replacing, I'm getting equation 3, which is the differential equation for the family of orthogonal trajectories. So to get orthogonal trajectory, let us solve equation 3. Then you will get orthogonal trajectory for the given curve 1. Let us solve one problem in polar coordinates. Find the orthogonal trajectory. OT, I will write orthogonal trajectories of the family of curves family of curves are equal to c into secant theta plus tan theta, are equal to c into secant theta plus tan theta. Solution. First, what is the given curve? C into secant theta plus tan theta. Is screen is visible and voice is clear?
Yes, sir.
Okay.
Yes, sir.
Take this as equation 1. And what is C is the parameter here. So differentiating this with respect to x, differentiate with respect to theta. Then this implies dr by d theta I will get C into, what is secant theta derivative? Secant theta derivative, secant theta into tan theta plus tan theta derivative secant square theta, secant square theta. So this implies dr by d theta equal to c into, what is the common? Secant theta is common. Then what I'm getting, tan theta plus secant theta, right? Then I can write this as dr by d theta equal to secant theta into c into, I will write secant theta plus tan theta. Okay. What is this value? This is from equation 1. This is nothing but r. This is nothing but r. So dr by d theta equal to what I'm getting, r into secant theta, equation 2. Automatically, what is this? Using 1. Using equation 1 can write, right? So what is C is eliminated now. Equation 2 is the differential equation of the curve 1, okay. Now what is the thing? To get orthogonal trajectory, what we have to do? Replace dr by d theta by minus r square d theta by dr in equation 2. Then what is this becomes? Then 2 implies minus r square d theta by dr equal to r into secant theta, right? I have to solve this. 1 r gets cancelled, so minus r d theta by dr equal to secant theta. Remember, not only the our methods, intermediate techniques also use, we can use, that is variable separable, like that. Okay. Now here theta terms are here, r terms are here, so I can separate the variables. So if I separate the variables, secant theta comes here as cosine theta, and this is minus 1 by r dr, so I will write like this one, 1 by r dr equal to minus cosecant theta d theta is variable separable form, okay. Therefore integrating on both sides, therefore integral 1 over r dr is equal to negative cosine theta d theta. So this is log mod r, you can write. And cosine theta integration is what? Minus sine theta, plus one more constant. I'm taking that already c is there, so let us use another constant k. Is the constant. Then what is this? This becomes, and I can take, I will take the constant in terms of logarithm. So what is this becomes? Log r minus log k equal to minus sine theta. That implies log r over k equal to minus sine theta, isn't it? So what is this? Is to the base e is there, so r by k is nothing but what? E to the power of minus sine theta, isn't it? So that is equal to r equal to k into e to the power of minus sine theta, is the equation of equation of family of orthogonal trajectories. Family of orthogonal trajectories. Okay, here k is the parameter. Here k is the parameter. This is one simple problem. Okay, next one, another one. Find orthogonal trajectories of r square equal to c into sine 2 theta. C into sine 2 theta. Solution. R square equal to c into sine 2 theta, equation 1. Okay, the given curve, c is the parameter. C is the parameter. Okay, then differentiate with respect to theta. Differentiate with respect to theta. Then this is what 2r and r derivative. R is always function of theta. R is always function of theta. So its derivative dr by d theta, and c into 2 cosine 2 theta. Then I have to eliminate c. So what is the c value? This 2 gets cancelled. R over cosine 2 theta dr by dt. Substitute c value in 1. Substitute c in equation 1. In equation 1. Then what 1 becomes? R square equal to, what is equation? C square. C. C means what? R by cosine theta dr by d theta into, what is the function? Another sign is there, sine 2 theta. So what is this? 1 r gets cancelled. So r equal to dr by d theta sine theta by cosine 2 theta tan 2 theta. Tan 2 theta. So I can write now. What is this? Dr by d theta is nothing but r cot 2 theta, equation 2. What is this is the differential equation of the curve 1, of the curve equation 1. Okay, so same logic. To get orthogonal trajectory, replace dr by d theta by minus r square d theta by dr, minus r square d theta by dr in equation 2. Then 2 implies what? Minus r square d theta by dr equal to r cot 2 theta. Now I think I can separate the variables. So this is minus r d theta by dr equal to cot 2 theta. So this is, take cot this side, tan 2 theta d theta equal to minus 1 over r dr. Correct? So I will write r terms first, equal to minus tan 2 theta d theta is variable separable form. Is variable separable. Variables are separated. That is called variable separable form. So integrating on both sides, 1 over r dr equal to minus integral tan 2 theta d theta. Right? So this is log r. What is tan integration? Sin by cos. Log secant now, isn't it? Log secant 2 theta. Log secant 2 theta whole by 2. 2 theta is there. Plus, since every term is in terms of logarithm, take the constant also in terms of logarithm, isn't it? Right? So that is equal to, I will take 2 LCM. This is, I can write, yeah, minus log secant 2 theta plus log c, 2 log c, 2 log c. So this is log r square equal to, isn't it? Okay, minus log secant 2 theta plus log c square, log c square. So this is log r square equal to log m minus log n, log m by n, c square by secant 2 theta, c square by secant 2 theta. So what is this is r square equal to c square by secant 2 theta. That is nothing but r square equal to c square into cosine 2 theta. Okay, one more change. Already constant c is there, so let me write this is k. Already this is k. This is k. Next, this is k square cos 2 theta. What is this? Again same curve. What is r square equal to c square c sine 2 theta? So here r square equal to k square cos 2 theta is the equation of family of orthogonal trajectories of for equation 1. For equation 1. Okay, this is one more problem, and you try this. Find orthogonal trajectories of the following curves. First one, r equal to c into cosecant theta plus cot theta. R equal to c into 1 plus cosine theta. Next, r equal to 2c by 1 minus cosine theta. Fourth one, r equal to c into e to the power of theta. C into e to the power of theta. And the fifth one, r to the power of n equal to a sine n theta. A sine n theta. And next one, r to the power of n cosine n theta equal to a power n. A power n. 2a cosine theta plus sine theta. Lastly, r equal to 2a into cosine theta plus sine theta. Okay, these are the problems based on orthogonal trajectories, polar coordinates. I will solve one problem. What is that? Either this or this. Fifth or sixth. Which one? Yes. Sixth one. Okay. Sixth problem. R to the power of n cosine n theta equal to a to the power of n. Equation 1. Differentiate with respect to theta. Then what is this is different? If I differentiate this one with respect to theta, first n into r to the power of n minus 1 and r derivative dr by d theta cosine n theta taken as constant first. Now r to the power of n constant, cosine n theta derivative minus sine n theta into n equal to what? A power n is constant, so its derivative 0, right? So what are the common terms? N into r to the power of n minus 1 is common, so remaining terms dr by d theta cosine n theta minus r power n minus 1 is common, so there will be one r will be there, r n sine n theta equal to 0, right? So which part is equal to 0? Dr by d theta bracket function cos n theta minus rn sine n theta equal to 0. Done. Okay, so this is equal to, what is dr by d theta then? This is rn sine n theta by cosine n theta. If any corrections, suggest me. This is equal to dr by d theta equal to rn into tan n theta. Equation 2 is the differential equation of curve 1. Okay, now to get orthogonal trajectory, what we have to do? To get orthogonal trajectory, replace dr by d theta by minus r square d theta by dr. Then 2 implies minus r square d theta by dr is equal to Rn into tan n theta. Rn into tan n theta. Then what is this? Minus r d theta by dr equal to n into tan n theta. So I will write taking r that side 1 over r dr is equal to taking theta this side. So minus 1 by n cot n theta d theta. Yes, any corrections? Dr 1 by r, n comes here as 1 by n tan cot, right? Is variable separable form. Is variable separable form. Therefore, integral 1 over r dr is equal to, n is the constant anyway, cot n theta d theta. So this is log r is equal to minus 1 over n. Cot n theta means log sine n theta whole by n. Is it correct? Whole by n. Any corrections? Log, right, that plus log k plus log k. So this is log r. Where is the mistake? Any mistake?
Sir, n will be cancelled, I think, sir.
Yes, just I'm checking that one. This is correct. N also taken common now, right? See here in this one, n also taken common. So there is no n here. There is no n here. Is it correct, right?
Yes, sir.
There is no n. This is not there. Just minus cosine theta, and this is not there. This is not there. Done. Okay. Then this is, if I take n common, this is equal to minus log sine n theta plus n log k. So this is log r to the power of n equal to minus log sine n theta plus log k to the power of n. So this is equal to log r to the power of n is equal to log m minus log n, k power n by sine n theta, log m by n. So the value is r to the power of n is equal to k power n over sine n theta, right? So this is r to the power of n sine n theta equal to k to the power of n is the equation of family of orthogonal trajectories. Family of orthogonal trajectories for the curve 1. For the curve 1. Okay. This is the topic. End of the second unit topic, orthogonal trajectories. Any doubts? Yes, any doubts? Now, so briefly, what we have seen in unit 2. Unit 2, what are the topics? Anybody? Exact differential equation, correct? Exact differential equation, first point. Second point, non-exact differential equation. Non-exact differential equation. In this, what we have learned saying, one is homogeneous differential equation. Okay. Second one, homogeneous differential equation, m dx plus n dy equal to 0, where m and n are same functions of degree, same degree. And the second case is what? Y into some function of xy dx plus x into some function of xy dy equal to 0. And the third case, what we have seen, 1 by n into dou 1 divided by n dou m by dou y minus dou n by dou x equal to function of x. Then what is integrating factor? E to the power of f of x dx, multiply the differential equation by integrating factor, and fourth one 1 over m dou n by dou x minus dou m by dou y equal to function of y alone. Then integrating factor is e to the power of integral g of y dy. Then these are the four integrating factors method to reduce non-exact to exact differential equation. And the third one is what? Linear differential equation. Linear differential equation. Fourth one is what? Bernoulli differential equation, right? Bernoulli differential equation. Next one, what is the next one? Riccati's equation. Riccati differential equation. And next one, what is that? Claret's form, right? Claret's form differential equation. And lastly, orthogonal trajectories. Orthogonal trajectories. In this one is Cartesian, another one is polar, another one is polar. Okay, these are the topics involved in second unit. Very easy topic. Always remember, if you want to score more, you must thorough with second unit. It's very easy and simple. Next, third and fourth, fifth units are tough and heavy syllabus. Those are so thorough with matrices. Unit 1, very easiest chapter, and unit 2, which is also very easy. Now class is open for doubts in second unit. Yes, any doubts?